Okay, so the next part of our lesson today is parts of similar triangles. So if you remember back whenever we started triangles first semester, we talked about these things, the altitude, the angle bisector, and the medians. Altitudes are from a vertex to the opposite side of the triangle, and it always makes a right angle. Angle bisectors are from an angle to the opposite side, and it bisects or cuts that angle into two congruent pieces. And then the median, again, is from the vertex to the opposite side of the triangle. It's not necessarily an angle bisector. It is a segment bisector. It cuts that opposite length or opposite side of the triangle into two congruent segments. Okay? So now we're going to look at these specific parts of our triangles within our similar triangles. So if two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. So what that means is if triangle ABC is similar to triangle EFG, the altitude BD over the altitude FH is going to be equal to AB over EF. Now, you could use any of the different corresponding sides for this second piece. Okay, one altitude over the other altitude is equal to, you could have said AC over EG, or equal to BC over FG. Because since these triangles are similar, I know that the ratios of all of the corresponding sides are similar or proportional, okay? So, the angle bisector. So I'm going to look at the line that is bisecting the angle. So QS over UW is going to be equal to QP over UT. Again, this second part, I could have chosen any of my corresponding sides. Okay? And then the last one, our median. Our median, so let's say JH over NL is going to be equal to GI over KM. Okay, so why is this going to be useful? It's going to help us figure out different pieces of our triangle if it's not all labeled. Okay, so looking here. So these are medians because it is cutting the opposite side into congruent segments. So I'm going to say SW, which is X, over TF, which is 15, is going to be equal to, I'll use 19.2, which is your SU. Now we need to figure out which should I use here. Well, this is side SU. SU corresponds to DC. So DC is labeled 24. You need to make sure that you choose corresponding pieces whenever you are setting up your proportion. And then we are just going to cross multiply. We're doing more cross multiplying to solve our proportions. So 24x equals 19.2 times 15, which is 288. And then divide both sides by 24. And we get x is 12. So the next one we are looking at altitudes because it is perpendicular to the side opposite of it. So 10 over 8 is equal to, I'm going to use x. Well, that's IH or HI, so that's going to correspond to LK, so I need to use the 14. So I'm going to cross multiply, and I get 8x equals 140. Divide both sides by 8, and we get 140 divided by 8 is 17.5. Okay, the next one, these are now angle bisectors because it's cutting the angle into congruent pieces, or congruent angles. So I'm going to do 32 over 24 is equal to 38, which is AC is going to correspond to EF, so that's corresponding to X. So we're going to cross multiply, so I get 32X equals 912. Divide both sides by 32, and we get X is 28.5. Okay. Next one, these are also altitudes. Remember, sometimes your altitude is going to be outside of your triangle because altitudes always have to be perpendicular to the side opposite it. So if I draw a perpendicular line from this vertex T, that's outside the triangle, but that's okay. This is still called my altitude. So 15 over 12 is going to be equal to 42. Well, 42 is side TU, or UT. So that's going to correspond to PQ. PQ is labeled X. So we are going to cross multiply, and I get 15X equals 504, and then divide both sides by 15, and I get X equals 33.6. So again, very similar to what we did on the first part of the lesson. We're setting up proportions and then solving for X. Okay, so now let's look at this one. And we only can do this whenever it says the triangles are similar. So that's why I'm able to set up these proportions, okay? So these are called your medians because it's cutting the opposite side into congruent segments. So I'm going to write 20 divided by x minus 5 is equal to 2x minus 9 over, so that's YC, so LH, which is 15. So this one's going to be fun because we're going to have to do some solving quadratics. So when I multiply these two together, I get x times 2x is 2x squared. And then I get x times negative 9 is negative 9x. Negative 5 times 2x is negative 10x. And negative 5 times negative 9 is positive 45. So I multiplied my x by both terms in my other part of my fraction, and then multiplied the 5 by both terms in the other fraction. And then that's going to equal 20 times 15 is 300. So when we are working with our quadratics, so anytime there's an x squared, you are going to want to move everything to one side of the equation and set it equal in order to factor. And we're also going to combine some like terms. So I have 2x squared. The negative 9x minus 10x becomes negative 19x. I'm going to move my 300 over. If it's positive on the right, I'm going to subtract it to move it to the left, so that becomes negative 255 equals 0. So the way I like to factor these is I do parentheses times parentheses equals 0. The only way to multiply and get a 2x squared is 2x and x. So then I'm wanting factors of 255. I know they're going to be opposite signs because that's the only way to multiply and get a negative. So I need them to multiply and give me 255. So you could do in your calculator, a way you can find factors is you can do negative 255. That's the number I'm wanting to find factors of, divided by x. Okay, so the number you're wanting to find factors of divided by x, and go to the table. We're only going to ever look at whole numbers, okay? So 1 and 255, that's really far away to give me 19. 3 and 85, still super far away. 5 and 51, still very far away. I'm skipping all of these decimals. I get another whole number pair. So 15 and negative 17. Let's see if this works. If I put negative 17 here, what's 2 times negative 17? It's negative 34. And then 15 times x is 15x. So I would have negative 34x plus 15x, which does give me my negative 19x. So it's minus 17 plus 15. Now remember, we did say you're not going to have any of these on your test or quizzes. However, you might have one of these as like a bonus question. So it's not a bad idea to refresh our mind on how to solve our quadratics. So when I have parentheses equaling 0, separate the parentheses, set them both equal to 0, and solve. So when I solve this, I get 2x equals negative 15, which is just x equals negative 15 over 2. And I move my 17 over, and I get x equals 17. Okay, so we can check our answers. Okay, can I have x being negative 15 over 2? Well, let's see. If I do negative 15 over 2 minus 5, that would let me know that this side length, this median, Lx, is a negative value. You never can have a negative length. So I know this is not an acceptable answer. So let's now try 17. 17 minus 5 is 12, so that works. 17 times 2 is 34. 34 minus 9 is 25, so that works. It gives me positive lengths. You always have to get rid of any answers that are going to give you a negative length. Okay, so those are our parts of similar triangles. Now we're going to go to the triangle angle bisector theorem. What this says is an angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. So what that means is, if I have this angle bisector BD, it is going to tell me that AD, because it's cutting AD and DC, or it's cutting AC into the segments AD and DC. So AD over DC is going to be equal to the ratio of the other two sides. So AB over BC. Okay. So let's practice some of these. So KM represents an angle bisector. Okay, so KM is an angle bisector, meaning the ratio of these two segments is going to be the same as the ratio of these two sides. So 4.8 over x is going to be equal to 12 over 18. And then we're just going to cross multiply, and I get 12x equals 86.4. And then we get x is 7.2. So again, KN is an angle bisector, therefore the side that the angle bisector is cutting or touching, intersecting, is going to be proportional. So 36 over 40 is going to equal x over 54. So I'm going to cross multiply, and I get 40x equals 1,944. Divide both sides by 40, and we get x is 48.6. So again, just another relationship. We're setting up proportions, cross multiplying to solve for our variable. Okay, so this next one's a little bit trickier because I have Km, which is my angle bisector. It's then going to say that this piece is broken up into proportional segments. It tells me the length of JM is 15, but it doesn't tell me the length of LM, so I'm going to have to calculate the length of LM. The whole segment's 39, and if JM is 15, that means that ML is 24. So I'm going to do 15 over 24 is equal to x over 36. And then we are going to cross multiply, and I get 24x equals 540. Divide both sides by 24, and we get x equals 22.5. Next one. So, again, it's telling me that JM is 12 and the whole JL is x. So I'm going to have to calculate what ML is. Okay? So ML is the whole piece, which is x, minus the half part, or the piece of the segment it gives me, so minus 12. So I'm going to do 12 over x minus 12 equals 18 over 30. So I'm going to cross multiply. So it's 18 times x minus 12. Notice how my denominator was 2 terms, so I'm putting it in parentheses. 12 times 30 is 360. So we're going to write equals 360. We're going to distribute our 18s. We get 18x minus 12 times 18 is 216 equals 360. I'm going to add my 216, so I get 18x equals 576, and then divide by 18, and I get 32. So x is 32. Okay, now our last one, and then we're done for today. Okay, so it again tells me just JM, and I know the whole JL is 45, so I need to find out what ML is. So I'm going to do 45 minus 27, and that gives me 18. So I'm going to do 27 over 18 equals 3x minus 9 over x plus 11. And we are going to cross multiply. So I have 27 times x plus 11 equals 18 times 3x minus 9. So I get 27x plus 11 times 27 is 297 equals 18 times 3 is 54x minus 9 times 18, which is negative 162. So I'm going to move my 162 over here. I'm going to move my 27x over here. So 54x minus the 27x is going to give me 27x. The 297 plus the 162 is going to give me 459. And then divide both sides by 27. And we get x equals 17. So there we go. So again, we're just setting up proportions, cross-multiplying to solve for x. Really, the only tricky part is making sure that you're setting up these proportions correctly. Notice that whenever I was setting them up, I did 27 over 18. And then, so 27 was on the top. So how do I know which of these to pick? Well, the 27 is in the same triangle as the 3x minus 9. That's why those are both in the numerator. Then the 18 is in the denominator, and the side that's in that triangle as well is the x plus 11. So that's why those both go in the denominator. That's how you know you're setting up your proportions correctly. Okay, I hope that y'all have enjoyed the 2 videos for today. Reach out to myself or Miss Cerna if you have any questions. Have a great day.